All right, hello and welcome back to these slides. So we'll finish them up, and then that'll be that. The final week of class will be for review with all the stuff that will be on the exam. But we had some fun talking about the lambda calculus, and hopefully it makes a bit of sense. Now I want to talk about something similar yet different. So we're still going to make something new. We're going to learn something new about programming. We're going to make our own language this time, okay? I have defined it, but let's pretend that we decided on it together, okay? We decided on this language, and here is how you define a language, okay? You have a bunch of different pieces that together make all the different parts of a language. So the whole program that you write won't be defined by this program rule, and so what it's saying is, it's 2 colons and an equal sign this time. This is how you define things. So I'm defining that a program be a bunch of statements. Everything in the parentheses, that's just extra information. This is what's really there. Okay, a program is statements, whatever that means. We'll get there. Okay, so a program is just a bunch of statements. That's what I'm defining a program to be. Okay, and then okay, what are a bunch of statements then? What is statements? Okay, you could have an empty program. So you can have an empty statement. That could be your entire program. That makes nothingness as a statements, but also you could have a sequence of other statements. So you can have one statement followed by as many statements as you'd like. So you try and use this rule again. So it's essentially a way to define trees in a special structured way. Okay, that's what this format is. It's a standard format that you'll learn about later, but I want to give you a little sneak peek. Okay, so a statement could be either a sequence of statements, which means it's a little statement with a bunch of other statements right after, reusing this rule all over again. It's recursively defined. We say inductively defined sometimes. Or it's just the empty program. So that's how you can stop, right? You'll follow this rule for as many statements as you need, and then finally you'll have an empty statement to end it all. Okay, it's like the null pointer. This is like a linked list. And then what's a statement? What are all the different things that we could do in our language? And so a statement usually is like something followed by a semicolon, right? So we could set a variable. We could say, okay, you put a variable on the left, you put this symbol, you put an expression on the right, and then you put a semicolon. That is a valid statement in the language. And we'll call that like an assignment statement. How about that? Okay. We could also print things. We could say print and then some expression that computes a value, that's the key, and then a semicolon. That could be a print statement, okay? This is our language. This is what we could write. We are defining the syntax of our language, okay? And, okay, we could also have if statements. That would be nice. We could say if some expression is true, then we do these statements, otherwise we do these statements, okay? And it's kind of custom to use capitals for all the things that are variable, like all these things that can be filled in with other rules, and lowercase for like members, concrete syntax of the language, like lowercase print. That's the idea. So there's our if statement, and then we can have a while loop as well, and that gives us a Turing complete language, so why not? While some expression gives back true, then we will do all these statements and just keep repeating them until the expression becomes false. Yeah, that is our language. And then finally, like, what is an expression? How is that different from a statement? The idea is that an expression gives back a value, okay? So for example, we can add 2 expressions that'll give back their sum. We can multiply them. We can check if one expression is less than another expression. If that's true, then we will give back true. Otherwise, we'll give back false or something. So maybe we should add other things. This is like, it's either this, or it's this, or it's this. That's why there's a pipe symbol. An expression could be a variable. It could be an integer. And I guess let's define the ability to have booleans. It could be a boolean value, which could be true or false. And we can go and define, okay, what does it mean for a variable to, what does the syntax for a variable look like? What does the syntax for integers and booleans look like? But let's just use your idea of them, okay? So this is how you can define the syntax of a language, okay? This is our specification for our brand new programming language. And so now we can write stuff like this. Here's a program. What does it do? X starts at 1 while x is less than 10. let's make it go to actually 10. Well, x is less than 11, print x, and then increment x by 1. Okay? So this is allowable. This is an actual program that matches our language specification because here's how we can build it. Let me show you. You start with the program rule. It's going to make a tree. And then every program, you only got one option. A program is just a bunch of statements. Okay? Statements. And then we have to use the statements rules to fill in the rest. Well, what is our program but 2 statements? Oh man, 2 normal little statements. So we will use the sequence rule to make 1 statement and then the rest. Some more statements. The first statement is going to be this assign, x equals 1. Okay? So we have variable and then expression assigned to b. Sorry, just 1 colon, huh? And the variable is x. The expression is just a number, 1. So I guess we'll use this rule, right? We're using the integer rule. Let's be pedantic. Integer, it's 1. And the other statements are all of these. So we have a while loop, which is itself a statement. So we got to use this rule one more time to sequence them, okay? Because we have 2 statements total, so we got to use this statements rule, the sequence. Whee! And then this last one is going to be lambda, okay? That's the empty statement, because we have 2 real ones. That's the idea, okay? And so this while loop is in our language because we can do this. We can be like while expression then statements. Oh man, while exp then statements. The expression is x less than 11. It is the exp less than exp rule. And then this first expression is the variable rule. We pick out x. The next expression is the integer rule. We give 11. See how this is all following from our definitions? Sorry I have to write so small, but I hope you get the idea. And then we have 2 statements. And so I think you can imagine what's going to happen here. We got to have a statement. We got to have some more statements. And this is like the assign. This is the print x part, which I think you can imagine is in our language with some dot dot dots. And then this one is again statement and statements. We have 2, so this last one's lambda. And so we have the print, and then we have the assign, which is assign dot dot dot. It's in the language, yeah? And so with this big long tree, it tells us how we go from this specification to a real program. You just got to replace the capitals with some of the rules. And those rules may be recursive. Eventually they get to their base cases. See that? It's really cool. And if this interests you, you're in luck for your upper division classes. Okay? So yeah, essentially this just makes a tree. This is how we can make sure that our language, the programs in our language, match what our idea of them should be. Okay? So that's our example program. And then the rest of this lecture is me making an interpreter for our language. Okay? Because I'm going to do it in Racket just to make it simple. The idea is our program is a tree, which we can make we can construct as a list of lists in Racket, which is quite nice, right? Our program is just a big list of symbols, right? Because it's just a bunch of statements, so it's a list of statements. Our first one is assign, yeah? Assign, and then we have the while statement, and then we can just have nothing left. It's a list, so it knows that we're done then. Then we have a while loop, and we can see, okay, we have less than x10, print x, assign x, plus x, and 1. Okay? So that's the simple version. Really, I should be saying var x, integer 1, var x, integer 11 this time, right? print var x. Assign, it's forced to take a variable, so we're good there. But we can include it for fun. Var x, and then we have plus var x integer 1. So it gets a bit more complicated, but this is still the idea, right? Maybe I should copy this and then go back to how it was. You got your simple way versus your complicated way. There, and this was supposed to be 11. Okay, so either way, you can represent this in Racket, okay? That is what I'm getting towards. And yeah, all that we have to do is write a program that can methodically go through programs that look like this, that have this kind of structure, and execute them, like run them. What does it mean to run? Okay, x equals 1. Let's finish that statement. It's all going to make sense, okay? So our job as programmers is to pull apart this list and execute it, all the little statements, in the right order, okay? So the last piece of the puzzle is that we need state. We need to keep track of the state of our program because we're assigning variables. So at like the very beginning of time, we have a state with nothing in it. And then once we say like x equals 42, then our state becomes, oh, x better hold 42. You see that? That's the key. That is the idea. And then we can say, okay, x equals x plus 1, and this makes sense because now we can look up in our previous state the value of x, make it, and then do the sum, make it 43, and then we can add x, or we can substitute x back in. So now our new state is x becomes 43, okay? So a state will keep track of the values of our variables, okay? So this is like the initial state, this is like the intermediate state, and this is like the final state of our program, of this little tiny program with 2 lines, okay? And I think I specified that we have to have semicolons, so let's just do that, okay? For our language, the state, all the state is the values of the variables. Okay. For more complicated languages like C++ and things like that, you have to keep track of things like the stack. That's all possible if you take a programming languages class, which I encourage you to take in your upper division. And they will be teaching you all of this stuff. Okay? It is fun. So yeah, let's write an interpreter for this language so that we can execute this program. Okay? That is our goal. So let us do this. I'm going to copy this. This is our program. This is the one we want to execute. So define P, I guess, as this big long list. And this is not supposed to be Unicode, so let's do that. And let's see if we can clean this up a little bit. We have a list with a bunch of things. Our first one is the assignment. And so after that, we have the while. Maybe we can do that. That will make it a bit easier to read. While that's true, do all these statements. Let's see here, which involves printing these this variable x, and then we're going to assign into x plus 1. Done. And I think, yeah, does that finish it off? That ends the while, that ends the statements, that ends the program. Yeah, that should do it. So this is what we want to execute. That is the idea. All right, so let's make this happen. And yeah, I think this should work. So right now, if I just like say P, if I just say P and it'll show it to me when I run this program, this is my program. Okay, it's just a list. It's just a list of symbols. Like assign is a symbol, remember? It's like this. It's really using this quote to quote everything. So assign is just a symbol. These are all just symbols that have no meaning right now. Our job is to give them meaning. Okay, so let's write, did I give it a name? I guess evaluate will work. but sometimes we don't get back values. So let's say like execute a program in a certain state. How about that? Yeah. So yeah, let's do this. Let's say define run program. Maybe we can call it run or something. Execute program P, whatever it is. What do we have to do? Okay, so a program is just a bunch of statements, a list of statements. So let's make a function. It's like, okay, all we have to do is execute statements, because P is just a list of statements, really, in an empty state environment. Okay, so we have to figure out what we want our state to be, and I think the best idea for the state is a hash table. Okay, so we'll give it an empty hash table to begin with, and that will be that. Okay, so now let's continue. Let's figure out how to execute a bunch of statements. Okay, statements, let's call it S, I guess. And so remember, there are two kinds of statements that we could have. We could have real statements. It's just a list of real statements, or there's nothing. Okay, so eventually we'll get to the end. And if we do this in list land, it's either we have a first and a last, or we have an empty list. Okay, so in Racket, either S is a non-empty list, or it is an empty list. Okay, so we're going to use something really cool called pattern matching, and here we go. Pattern matching, it looks like this. It lets us match on the structure of the list, which is really cool. We can break it down. We can see if it has a first element and a rest, and we can give those names. It's quite nice. So we just say match the thing, and then we give some options in between these braces. Okay, so let's do it like this. We say match. We're matching S, and we know it's a list. It's a list of things. Let's figure out what kind of list of things it is, though. So either it is a list with more than one element. It has a first statement, and then it has a bunch of other statements after it with a dot, dot, dot. So these two things together, the statements and the dot, 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 match the rest of the list. And this one matches the first thing in it, the first statement. And so if that's true, then we'll do something. And otherwise, the list is empty, right? Then we just have an empty list like that. And we can then do something else. Okay? So that is how we do it. That's how we can execute a bunch of statements. Okay, so now we have to figure out what do we do here, right? How do we execute this rule, this sequence of statements rule? Okay. So our program, again, looks like this. We've got our first statement, and then we got some more to run. And the order matters, right? So what we should do is run this statement first, and then run the rest. Yeah, that's quite nice. So, to execute a sequence of statements, run the first statement. So we'll make a rule, execute statement. Give it that statement. And, oh sorry, we also have a state that we're passing along. State in a state. And yeah, then we'll have to do something in a second. We'll get there. And then after that, we just run the rest. Okay, and that is a recursive call to this function. It's a smaller list of statements, so we're good. So we say execute statements, and then we got to give some state. Okay. And again, I'm not expecting you to understand most of this, but the little pieces that peek through into your brain are very important. Okay, so the idea is the state will have changed. The state will have changed after we executed the statement, most likely. especially for our first program, because this one has an assignment. It's going to change the state of the program. It's going to make the state that. This is just a variable. We can't really talk to it recursively. We can't like pass references in Racket. So what we need to do is have, every time we change the state, we return back the new state. Okay? So here's what we can do. We can say define new state, the result of executing this one statement in the first state. And I guess I'm going to have to figure out why it's not letting me put parentheses sometimes. So there it goes. Okay. So we're going to get back a new state after we execute this first statement, and then we're going to run the rest of those statements starting from that new state. See that? That's the key. Okay. And then, if we have no more statements to execute, we just do nothing. And in Racket, we have to say something here, so we can say null. Like, give back the empty list, please. Do nothing. So that is how you execute a bunch of statements. Cool, huh? That's the idea. So then, we have to keep going. Now, how do we execute a single statement? Okay, this is how we break it down. It's just a bunch of little functions that talk to each other. Define, execute, statement, call it S again, in a certain state. Okay, now, what are we going to do? So, the idea is, this statement, we can figure out which one it was. Okay, we can figure out if it was an assignment, a print, an if-then, a while, all these things. We can figure out which one it was by doing another match, because the idea is each individual statement is another list. Isn't that crazy? It's just another list. So you can match on it. We can see which kind it was. Okay, and yeah, that is the hope. So we can say something like match S with, okay, what are our options? So it'll be like, the option 1 is, maybe it was an assignment statement. It has a list with assign at the front, and then it has two things, right? An assignment statement always has the variable that we want to assign to, and then a number that we want to give back, okay? So assign with a variable, assign it a, I don't know, assign it some expression, right? Some expression's value. And so I think I don't want the variable part here. Let's just keep the x, because we can get the x immediately that way. And so every time we have an assign, let's do it like that instead. Okay, let's just put the variable right out there, which more matches this rule, actually. So I'm happier about that. So let's just say x here. Let's just say x here. Okay, so we have the variable, we have an expression. What do we do? What do we have to do here? The idea is, again, we got to get the answers, okay? To evaluate an assignment, to run an assignment statement, figure out the value of exp, because it might need to be like, it might be a bunch of pluses or something. We need to get a value back, and then store the answer into the state. At variable v. Yeah, that's the hope. So here's what we'll do. We will say, well, let's figure out the value of the expression. Define exp val. That is, okay, eval, or execute expression exp in some state, always in the original state. That is the idea. And this one, it's just going to give back the value. The expressions, I've taken care to make sure that they can never change the state. The only thing that can change the state is the assignment statement. Okay? That is the idea. So we have that. And, okay, we now have the value of that expression. Now let's plop it into v. Okay? And so we have to just talk to the hash table. Okay, so we started with a hash table. Now we got to put a value in for v. That is the hope. So I need to go up and look at how you do that in Racket. I'll go search for it, and I'll be right back. All right, here it is. It's hash set to set a value. You give the hash table, and then a key, and then the value you want to set there. Okay, and to get it back, you use hash ref. So that'll come in handy. All right. So to put a value there, we say hash set exclamation point because we're updating it. We update the state at v. We're going to put the value xval. See how we're doing that? That is the idea. That is how we do that. So that should be happy there. That's assignment. Otherwise, our what's the other kind of statement we might have? It looks like I have while and print. So let's do maybe print and then while, and that'll be that. And I encourage you to do the rest, to do the full language. You'll use the same kind of style. So print, and then print, you can print an expression. Okay, so let's see here. To print something, we need to first figure out the value that we want to print. Because again, maybe it's something like, I don't know, print x plus 2. We need to go look up x, we need to go add 2 to it before we can actually give back some value and print it to the screen. Okay, so that's why we have to always evaluate this value to get its value. And so we'll just execute it again. We'll say xval is that. And this time we don't set anything, but we print. And so in Racket we can say printf and then twiddle a new line, please print whatever xval was to the screen, really in Racket. Okay, so that's how we can print something. And then the other kind of statement that I'm including in this sample program is a while loop. Okay, so let's go through that one, and that'll be that. Okay, so the other kind of statement in this sample program is a while loop, which starts with the symbol while, and then we give the expression to check. That's like the condition. Let's call it cond maybe. And I don't know if I'm allowed to say cond, but we'll try. We check the condition, and then we do the body. Okay? That is what a while loop looks like in my language. Because we've got this one expression that is going to give us back true or false, hopefully. And then we have all these statements as the body. Okay? And let's remember that the body is a bunch of statements. Because we can't use execute statement, we got to use execute statements for that one. Okay? It's a bunch of functions that are recursive and call each other. Okay? Please yell at me if you have any questions at all about this, though I'm definitely not going to test you on it. Okay, so the first thing we need to do is figure out, should we execute the body? We need to make sure that the condition is true. All right, so the first thing we need to do again is get the value of that condition. And so it's, I guess we can call it cond val. Execute cond in our current state. And okay, if it was true, we'll do one thing. Otherwise, we'll do a different thing. Okay, so I guess we can probably use Racket's if, actually. No, we can use Racket's cond. Cond, so either cond val was true, if that was the case, let me just confirm that Racket lets you do that. Can we say equal true, true? No, we can't. That's only for numbers. That one works though? EQ question mark? Okay, let's try that one. If we get back true, then we'll do one thing, then we'll otherwise do something else. Okay? I guess technically we can condition on cond val itself. because that'll check if it's true. Okay, if conval is true, then we will do the body. We'll do the body. So that means we execute the body statements when conval is true. So then that means we have to say execute statements. Where's the body? Body statements. And we do that in our state. Okay, that's what we do if it's true. And then remember that it's a loop, right? It is a loop. So we need to do it again, okay? We need to do it again, all over again. So if the condition is true, execute the body once. And then we need to execute the whole loop all over again. Try, at least. Okay, which involves getting back new state. And that'll look like that. Oops, I put accidentally a bunch of parentheses where they shouldn't go. That looks like we define a function if I do it that way. Sorry. We don't want that. So define new state, execute these statements, these body statements in that state, and then we execute the loop all over again, which we can just call ourselves execute statement S in our new state. Because S was the loop. Okay, and that's how you repeat a loop. You just keep on calling yourself as long as the condition was true. Oops. Isn't that cool? Isn't that cute? So yeah, that's the first one. And then else, then we're done. Okay, if the condition was false, we do nothing. We can just say null again, I guess. That should work. Okay, so that was that one. Can't actually do that now, can I? That can go there. What else needs to be here? Then we have that, and that's to define. I guess it's better style to put the comment above, huh? There. So then we can do that. Okay, is Racket happy with this syntax? It seems to be. Now it's complaining about execute expression. So we need to figure out how to execute a single expression. So, execute an expression in a state. How do you do it? Well, all we have to do is figure out what kind it is and give back the answer. Okay, so again, it's a match. And like everything else in Racket, every expression is, well, it's going to be a list of things. It's either a list with the symbol variable and then a variable name, or a list with a symbol integer and an integer name, or it's a list with plus at the front, the plus symbol, and then two other smaller things, or a list with the less than symbol. I think you get the idea. Okay, so let's do the easy ones first. So if the expression looked like this, if it was a list with var, let's do var first, some var v, we need to get the value of v. What do we give back? Well, we just look up this variable in our state. Yeah, that's the idea. And so to do that, we say hash ref. Hash ref the variable in our state. And I think I did it backwards. Hash ref the state for the variable. That should do it. Okay, that's a variable case. If we have an integer, the integer is the first thing in the list, and then we have an I, and the answer, the execution of the integer, what do we give back as its value? What's that integer? Okay, 42 evaluates to 42. That's all. Okay, now we have the list plus. We have E1 and E2 maybe, two expressions, two inner expressions. What do we do there? Well, this, we need to recursively figure out what E1 and E2 are. Maybe it's like x and 2. We want to add x and 2. because at the end of the day we want to add them. Yeah. So we'll say, okay, what's E1? E1's value is execute expression E1 in our state. Yeah. Same for E2. And then we can add them. We just give back their sum, the Racket version of the sum with the actual plus. Praying that they were really numbers. Otherwise we'll get an error. Okay, and then finally we have our last option is, we did var, we did integer, then we had plus. Our last one is less than. That's the last one we use. Okay, so let's do less than now. So less than, again, we have two things to see if the first thing is smaller than the second thing. So it's not so that we can add them anymore, it's so that we can compare them. Figure out what E1 and E2 really are. And then we'll just give back true or false, depending on whether or not E1's value was smaller than E2's value. Yeah? That is the goal at the end of the day. And so that can end that can end the match, that can end the actual function. And if it's happy, we're done. And I don't think it is. Okay, what's wrong, Racket? Dun dun dun. It doesn't really tell us. I have used some weird values, and these might be special values that I can't use, but we'll try. We'll see. Let's see what it says. Okay, define not allowed in an expression context. Oh, okay. So line 40, for example, I can't have this variable here. Because I'm inside a cond, I can't make new variables. I have to say something like let, which is quite unfortunate. Let's see here. I wonder if I could... No, I have to do it here. You know what? Something I could do is maybe put this all inside of itself. But no, I think the better answer is to use a let. So I can say let new state be the result of all of this. Sometimes Racket's just not happy about you putting a define in some places. That's all. So then, okay, so that's where our let goes, and then the body of the let can be what we do with that new state. I think that'll make it happy. Yeah? Let's try that. Else not allowed as an expression. Okay, yeah, something else is messed up. I'm going to have to look at this for a second. I don't want to waste your time, so I'll be right back. Aha, did you notice it? It was because I reused this cond, and then I tried to use the actual cond in the language. I overwrote it. Can't do that. So let's replace this cond with like underscore cond or something. That should fix all of that, which is funny. Is it happy now? That was interesting. Okay. Then I say 48. What's wrong with 48? Dun dun dun. Unbound identifier. Is it unhappy with the way that I'm matching things, maybe? Oh yeah, I think it is. So it looks like it can just do that itself. Okay. Was it going to complain about these? It was not. That worries me. Well, we will figure this out. Oh no, I'm sorry. What it was complaining about was this v. Was this v right here. I was using var instead of v. That should make it happy. Okay, now is the moment of truth. Let's see if it does anything right. We do execute program, right? That's what we had, and it was p. Whee! All right, so it looks like we have some problems. I will fix them and then get right back to you. Oh, silly me. What I did was I forgot to, you know how I promised that I always want to give back the new state every time I execute something? Guess what I didn't do ever was actually give back that new state. So let's do that. The result is always the new state after we execute things. So technically this one's going to work because it's going to give back the result, which should return a new state. If we're ever done with something, though, we don't say null. We give back our state, our current state. Okay, that's our answer. That's always the answer. Okay, and now for executing each individual statement now, we always have to give back the new state. So, for example, when we set this, we've got to give back the new state to whoever called us. So we just updated the original state, so we're good there. Same for this one. I'm going to say state. We didn't change it that time. This one, definitely. Original state. This one is, it should be giving back the new state because it's going to recursively evaluate itself. Okay, that's looking a bit better. And then expression just gives back a value. And I think we're always remembering to do that, at least. Okay, let's see if it's happier now. Look at us. Okay, so that finally did it. Okay, it took enough time, but we got there in the end. We just made a program that runs programs. Okay, it was a bit rocky on the way because I haven't done this before in Racket, but it was a good learning experience for both of us, I think. We have made a program. We have made a bunch of functions to inspect this. It's just a big string of symbols and actually do something with it. We'll execute a bunch of statements. We'll execute an individual statement in a certain way. We'll execute a single expression to give back a value that we could use maybe to assign things, maybe to print things, maybe to control a loop. And then they all work together in harmony by enough recursion. We end up printing from 1 to 10. Isn't that so cool? So I think that's where I want to end. Thank you for putting up with me as I discover how to do this in Racket, but I think the end result was a good one. So that is officially the end of these slides, and so we'll come back next week and it will be all about review. Okay, so I'll review for the final, and that will be our last week of class together. So I will see you then.